Launch the Grid Math program from the ModOps Grid Math pull-down menu. Let's start out by setting the Leadville limestone top as the initial grid. For the type of operation, select the Grid minus Grid option. Specify the Leadville limestone base as the grid that will be subtracted from the Leadville limestone top grid. Type in Leadville limestone Isopach for the name of the output grid. Enable the 2D Grid Map option and turn on the colored intervals, contour lines, labeled axes, and peripherals options. Expand the Peripherals tab and turn on the Color Legend option. Press the Continue button and you should see a map similar to this one. The elevation units within the upper and lower grids that were used to perform this operation were in meters. Therefore, these thickness values are also in meters.
Select the Stats Single Grid option from the ModOps Grid Statistics pull-down menu. Set the input file to the Leadville limestone Isopach grid that was created within the previous exercise. Click on the Output Options tab and select the RWDAB option. Check the Display Output option and choose the New Tab sub-option. Click the Continue button and a new tab labeled Stats Single Grid will appear. Nestled among a slew of grid statistics is an item labeled Model Volume. The volume of approximately 1 million cubic meters was computed by totaling all of the grid z-values and multiplying the result by the cell area, or the x spacing times the y spacing. Now, let's say that we're only interested in quarrying limestone that's at least 20 meters thick. Close the Grid Statistics program and select the ModOps Filters High-Low Filter program. Select the Grid Names tab and set the output grid to the Leadville Isopach that we created within the previous exercise. Set the name of the output grid to Leadville Isopach greater than 20 meters.rwgrd. Click on the Filter Option tab and configure the program to set all grid node values less than 20 meters to a null or non-existent value. Turn on the 2D Grid Map option and click the Continue button. A new RockPlot 2D tab showing the filtered Isopach will now be displayed. Now, let's say that we don't want to quarry these 3 isolated outliers. Close the filtering program and select the Edit option from the ModOps Grid drop-down menu. Click on the Open option from within the Grid Editor program menu. Select the Leadville Isopach greater than 20 meters.rwgrid file within the Open menu. We will now see a map depicting color-coded cells that can be interactively changed by moving the cursor over them. Set the replacement value to the null setting. Click on the Change button. Move the cursor over the cells to be changed to null while holding down the mouse button. Click the Save button and close the Grid Editor program. Reselect the Stats Single Grid option from the ModOps Grid Statistics pull-down menu. Change the name of the input grid to Leadville Isopach greater than 20 meters.rwgrd. Press the Continue button and make note of the new model volume. The filtering and editing has reduced the volume from 998,726 cubic meters to 405,081 cubic meters. Based on a limestone density of 2.6 metric tons per cubic meter, this translates to 1,053,211 metric tons. This is equal to the weight of 133,000 African elephants.
At some point, you may need to assign grid or solid nodes inside or outside of an area, such as a property line or excavation pit, a value of 0 or some other number. To view a list of the current Polygon tables, select the Project Manager tab. Expand the Map Model Tables group. Expand the Polygon Tables group. Double-click on the Polygon 2 table. This will display a datasheet that lists the X and Y coordinates for the vertices of Polygon 2. To display this polygon as a 2D map, click on the Plot button. Rather than getting bogged down with the nuances of the self-explanatory polygon plotting program, let's just click the Continue button. A new RockPlot 2D tab with a map of Polygon 2 will be depicted. Let's assume that Polygon 2 delineates the perimeter for the excavation of an underground storage system. Close the polygon and launch the Polygon Clip program from the ModOps Grid Filters drop-down menu. For the input, select the ahorizontop.rwgrd file that we created as part of the stratigraphic model within exercise 3. Enter excavationsurface.rwgrd for the output grid. Click on the Options tab and select the Polygon Table option within the polygon defined by group. Click on the pull-down arrow and select Polygon 2. Select the interior filter type and set the new interior value to an elevation of 1,720 meters. Click the 3D grid diagram option and press the Continue button. After a few seconds, you should see a 3D diagram that looks something like this. Click on the Save button and save the diagram as excavationsurface.rw3d. Next, we're going to isolate the materials that need to be excavated in order to perform detailed volumetric estimations. Launch the Solid and Grids program from within the ModOps Solid Filter pull-down menu. Select the Modify Existing Solid model and specify Lithology1.rwmod for the input model. This is the model that we created in Exercise 4. Set the output model to excavatedmaterial.rwmod. Click on the Filter Options tab and select the Single Surface option. Set the surface type to Grid Model and enter excavationsurface.rwgrd for the name of the grid file to be used as the filter.
Enable the Modify Nodes Below Surface option. Activate the 3D Solid Diagram option and set the block diagram type to voxels. Set the color scheme to lithology and click the Continue button. The program will now display the excavated material.rwmod model, which only includes lithologies within the original excavation polygon. Close the Solid and Grid Filters program and run the Volumetrics program located within the Borehole Operations Lithology pull-down menu. Set the input model to the excavated material.rwmod that we just created. Set the output to an Excel file called excavatedmaterial.xlsx. Click on the Set to Project Values button to automatically set the upper and lower sampling intervals to the project dimensions. By setting the interval to 1, we will be creating a report that provides volumetric summaries of the lithologies encountered at 1 meter intervals. Click the Continue button and an Excel report will be created. This report lists the relative percentages, surface areas, volumes, and tonnages for all of the lithotypes encountered at the user's specified intervals, which is 1 meter in this example. The mass computations are based on the density conversion factors listed within the lithotypes table. The output units are defined within the Units tab located at the top of the main RockWorks screen.